What is happening here? I update the cell initial state, then H naught. After this, it will gonna pass this I to the along with love and also NLP. Then X3 will be dot. Now next state will be predicted based on the all the all the sequence of the inputs, all the sequence of the input. RNN comprises repeating the neural network cells that are connected to the chain of like structure, where the output of the one cell is passed to the input of the next cell, input of the next cell. That's how it works. X recurrent layer, then we use final layer. It can be recurrent neural networks can be used for predicting of a sequence, predicting of an output based on the sequence of input. That could be a time series prediction because sequence of events, right? Yes or no? But there is a problem that it cannot remember the most of the previous informations. Okay, that is the issue of RNNs. Sir, if RNNs are the issue, then what is the way forward? We will see that forward. Sequence of input pass చేస్తున్నాం. ఇది ఈ లవ్ అనేది ప్రీవియస్ ఇన్ఫర్మేషన్ ఏందన్నా? ఐ ఈజ్ మై ప్రీవియస్ ఇన్ఫర్మేషన్. ఎన్ఎల్పి అనేది లవ్ అనేది ప్రీవియస్ ఇన్ఫర్మేషన్. RNNs may not remember I when it goes to the NLP. It will remember only the love. So it won't remember the entire context. Whenever you wanted to predict the next sequence, do you need the entire context or not? Entire context. That is what the problem with RNNs. Okay. To overcome this, we have something called LSTM. Time is more important. పాస్ అవుతున్నప్పుడు మొత్తం ఇన్ఫర్మేషన్ అప్డేట్ చేసుకుంటుంది. ఒక్కోసారి ఏం చేస్తే మిస్ అయిపోతుంది. రికరెంట్ న్యూరల్ నెట్వర్క్లో ఏమవుతుందంటే ప్రాబ్లం ఏంటంటే ఇట్ కెనాట్ హోల్డ్ ద లాంగ్ సీక్వెన్స్ సెంటెన్సెస్. If I pass long sequence of 100 lines, it cannot remember exact context. What is in the sequence? That is what the problem with RNNs. So in order to overcome the RNN, we have something called LSTM. Enna? ఇది కావాలి నాకు. ఏంటిది ఇది? ఈ ఇమేజ్ కావాలి. ఈ ఇమేజ్ ఎట్లే వేసుకోండి. నేను ఇమేజ్ ఎందుకు రాయలేదంటే ఇక్కడ ఓకే. First focus on LSTM. What is this, Nana? Long and short term memory. What it mean of long and short term memory? What is short term memory? Remembering for small time, then you will forget it. Okay. For long term is that you are remembering the data into the long term. Here in LSTM is a very popular architecture to handle the long sequences. What is this, Nana? Long sequences. In LSTM, we have three layers. One is input gate and another one is forget gate. Sorry. Okay, మనకి ఎన్ని ఉన్నాయి? Input gate, forget gate, output gate. In this particular example, this particular piece is what, Nana? Input gate. What is this? Input gate. This is the cell state. You are taking input and you are passing it and you are making that. What is this? Sigmoid. Sigmoid will produce what, Nana? 0 and 1. What it means? 0 means pass the information or remove the information. 1 means pass the information. 0 means remove the information. So this will be connected here and you are being multiplying it to the cell state. Then again you have here one more sigmoid, another we have one more sigmoid, then we have the tan H. This also we have the forget gate. What is this, Nana? Input gate, and what is the another one is, Nana? Forget gate. What is the forget gate will do? Forget gate, okay. Forget gate help us to forget or want to move. And the problem with RNN is, what is the problem, Nana? Vanishing. What is meaning of vanishing gradients, ma? The gradient become what, Nana? 0. So in order to not to make the gradients to 0 in a back propagation, what we are using here in this layer, we are using tan H. Tan H will produce the values between -1 to +1. So there is no negative here. There is no vanishing gradient will happen in the LSTM. There is no vanishing gradient happens in the LSTM. So it means that here in the LSTM, the ideally LSTM will remember or forget, will remember what is necessary, and forget what is not required. What is not required. Agree or not agree? So forget gate, what is the first one, Nana? First function, we are applying what? Sigmoid function. In that image, right? ht minus 1 we have, right? And we multiply with ht1 into x1 with the weights. We'll have a weights, right? And we'll apply the sigmoid here. What will happen, Nana? You will have the 0 and 1. What will happen? 0 and sigmoid function w of weight of function ht minus 1 comma x comma t plus bias. We'll have some bias, right? So sigmoid function will make what, Nana? 0 means don't let, remove. 1 means pass through the information. Okay? This is what gate, Nana? This is what forget gate, right? This is what forget gate. Forget gate equal to sigmoid of input and this one, right? This is what forget gate. What is input gate, Nana? Input gate shows that input gate responsible for addition of information. This addition is the 3-step. Regulating the values to be added to the cell state involving the sigmoid function. It's very similar to the forget gate and acts as a filter of information from ht minus 1 to what, Nana? ht minus 1 to ht. ఏమంటున్నాడు xt minus 1 to, where is this, xt minus 1 to xt. This is also works as the same, but it's a different. Creating a vector containing the possible values can be added to the cell state. This is done through the what function, Nana? Tan H function. So in this function is, this is input gate, this is what, Nana? Oh, sorry. This is forget gate, right? This is the first one is forget gate. This is what? Input gate. This is what? Output gate. Now the function output gate will be creating, the output gate decides the which part of the neural networks makes the output of it. Okay. Now next is, first we have written about this is forget gate, right? The forget gate formula is this one, and we have input gate. What will happen? Input gate, input, right? This is F2, forget gate. This is input. IT equal to sigmoid of Wi ht minus 1 comma xt plus b of I. Sigmoid what will do, Nana, here? sigmoid decides which layers needs to be updated. What is this in input gate? What layers needs to be get updated? Forget gate, what needs to be passed? Yes or no? Forget gate will decide that what information is to kept and what information is to remove. In the input gate, what value of the input and needs to be updated. Then output will be, the CT will be, what we need to apply, Nana? Tan H and same function, right? Tan H gives the values will be added to the stage -1, 1. It will stop or overcome issue of what, Nana? Vanishing gradients. Vanishing. Then what is the output gate, Nana? Output gate is to which output gate may what they will use, Nana? What they were using here? Sigmoid. What they were using? Sigmoid. The sigmoid function will be used which part of the information need to be passed as a output. Which part of the information pass as a output. So output OT is output, right? Equal to first what we need to apply, Nana? Sigmoid. What we need to use? HT equal to output into tan H of CT. CT ekkada calculate chesam kada manam ikkada? CT we calculated here, right? Yes or no? This is what it happens. Okay. Now LSTM. What is the main purpose of the LSTM, Nana? LSTM is the core component of the recurrent neural network, where the recurrent neural network fails to understand or hold the sequence of the words, where LSTM can help us to memorize which of the things needs to be memorized and also which things needs to be not to memorize. Yes or no? So that's what LSTM is an advanced version of recurrent neural network. LSTM is a family of recurrent neural network. What is this, Nana? LSTM is a family of recurrent neural network. It is not a separate different. It is in the form of neural network where you wanted to store the information and needs to get update the informations. Yes or no? In LSTM, how many things we have, Nana? LSTM lo any gates unnai, Nana? What are the 3 gates? Input gate, forget gate, output gate. First is what, Nana? Forget gate. What is the forget gate will do? Forget gate will be applied on the input and the sigmoid function, where sigmoid function will produce the values between -1 to 1, right? 0 to 1. If it is a 0, you need to remove that. If it is 1, you need to pass it to the next state, cell state. Then when it comes to the input gate, you are applying the sigmoid function and you wanted to update the layers with the information. Okay? Then again you are applying the tan H to overcome the issue of what, Nana? Vanishing. What is vanishing gradient? What is vanishing gradient? When it goes to the back propagation, your gradient becomes 0, 0, 0. Derivative at 0 is impossible. That is called vanishing gradient. So the final output is which part of the information need to pass as a which part of the information need to pass as output. That will be taken care of what, Nana? Sigmoid function. Sigmoid function only, right? Sigmoid function because it produces the 0 and 1. Okay? Then you are multiplying this output by what, Nana? Tan H of CT is what, Nana? Input gate. We want to take the input gate. Understood or not understood? Everybody understood or not understood? This is also a limitations. LSTM also fails in some of the cases. That's where the transformer came into the picture. We are going towards the transformer. First, you write this. Oh no, short-term memory is sigmoid function will remove the what is not needed. That is what the short term memory. The long term memory is which is passing towards the next layers. That is what the long term memory. Understood or not understood? Good. మంచిదే. డౌట్ రావడం మంచిదే. శుభ పరిణామం. శుభ ఏమి నామం? ఏమి పరిణామం పోండి. దీనికన్నా this is forget gate, this is input gate, this is what nana? Output gate, right? Last control. First piece is what nana? Forget gate. This is input gate. This is output gate. Okay? Clear?